Hello everybody, we will start the study of Chapter 6, the analysis of investment projects from this section. In Chapter 5, we discussed how to apply discounted cash flow analysis to some of the major financial decisions that people face in their personal lives. In this chapter, we will apply those same techniques to the analysis of investment decisions by business firms. Let's see the Section 1, the net present value investment rule. In Chapter 4, we have studied how to compute the discounted present value of a project with simple cash flows and make decisions according to the net present value rule. In this section, we will discuss how to apply the investment criterion into projects with complex cash flows. Firstly, let's review the calculation of the net present value by an example. Suppose that your brother would like to borrow $10,000 from you. He promises to return $12,000 to you 1 year from now. If the opportunity cost of capital is 10%, what is the net present value of this investment? The cost of capital 10% means if we did not invest it in this project, we could earn the interest rate 10% somewhere else. In this example, the FV is $12,000 and the interest rate is 10%. By the formula of present value factor, the PV is equal to 12,000 over 1 plus 10% to the first is $10,909.1. Since the net present value is equal to the difference between the present value of all future cash flows minus the present value of all current and future cash outflows. Here, the PV of all cash inflows is $10,909.1 and the PV of all cash outflows is $10,000. So the net present value NPV is equal to $10,909.1 minus $10,909.1. According to the net present value rule, accept a project if its NPV is positive. This investment is worthwhile because of the positive NPV. A project's net present value NPV, on the other hand, is the amount by which it is expected to increase the wealth of the firm's current shareholders. Like the one in Chapter 4, the NPV rule is invest if the proposed project's NPV is positive. Let's see how to calculate the NPV of a project by an example. Generic Jeans Company, a manufacturer of casual clothing, is considering whether to produce a new line of jeans called Proto Jeans. The cash flow forecasts for the Proto Jeans project are shown in the following table. A negative sign in front of a cash flow forecast for a particular year means a cash outflow. The table can be illustrated by the timeline as follows. It requires an initial outlay of $100,000 for new specialized equipment, and the firm's marketing department forecasts that given the nature of consumer preferences for jeans, the product will have an economic life of 3 years, and there will be $50,000 cash inflow at the end of the first year, $40,000 cash inflow at the end of the year 2, and $30,000 cash inflow at the end of year 3. At an interest rate 8%, this table shows the calculation procedure of the net present value of this Proto Jeans project. At time 0, the PV of the initial cash outlay is equal to itself minus $100,000. The PV of the cash inflow, $50,000, at the end of the first year is equal to 50,000 over 1 plus 8% to the first, and is $49,296.3. The PV of the cash inflow, $40,000 at the end of the second year, is equal to 40,000 over 1 plus 8% to the second, and is $34,293.55. And the PV of the cash inflow, $30,000 at the end of the third year, is equal to 30,000 over 1 plus 8% to the third, $23,814.97. For the fourth column, the cumulative present value at time 0 is equal to the PV at time 0. The cumulative present value at the end of the first year is equal to the 1 at time 0 plus the PV of cash inflow, $50,000. And the cumulative present value at the end of the second year is equal to the 1 at year 1 plus the PV of cash inflow, $40,000. Consequently, the cumulative sum of the present values of all of the cash flows lead to the NPV of this project, $4,404.82. This NPV means that by going forward with the Proto-Gene project, management expects to increase the wealth of the shareholders of the Generic Genes Company by $4,404.82. In summary, this calculation procedure of the NPV can be expressed by the formula sum CFT over 1 plus 8% to the teeth, with t from 0 to 3, and CF0 is minus 100,000, CF1 is 50,000, CF2 is 40,000, and CF3 is 30,000. In general, the NPV of a project is given by the following formula. NPV is equal to the sum of CFT over 1 plus k to the teeth, and t from 0 to n, where t represents the teeth period or year. CFT represents the cash flow of period t, and k represents the capitalization ratio of discounted cash flow, which is called the project's cost of capital. Let's apply this formula to a quiz. Suppose that the Proto-Gene project is expected to have a third-year cash flow of only $10,000. If all other cash flows are the same and the discount rate is still 8% per year, what is its NPV? This means the cash flows are CF0 is minus 100,000, CF1 is 50,000, CF2 is 40,000, and the CF3 changes to 10,000. Apply the formula of the NPV for projects. NPV is obtained as minus $11,471.83. In summary, we have studied the calculation of the net present value NPV for a project with multiple cash flows in this section. That's all about this section. Bye.